Good morning. This is Mike McGinn, your online instructor for Cisco Network Academy and Chapter 2, Configuring a Network Operating System. And this is for class Net I-105. It's 5:10 in the morning on Thursday, September 1st, 2016. Um, yeah, I'm bright-eyed and bushy-tailed, I can tell you. Well, today what we're going to do is we're going to talk about Chapter 2, and basically they kind of refer to it as um, iOS Boot Camp. And I'm just going to kind of hit the highlights of the chapter, and we'll kind of see how it goes here. So um, I'm going to go ahead and share my screen, and we're going to kind of cruise through the Net Academy chapter here. Um, they start out in chapter 2 talking about what is an operating system. And what an operating system is it's basically the brains of the computer in terms of what it can do. Maybe the brain isn't the right word. I guess it's kind of the manual, the operating manual for the hardware. Um, Windows 7, Windows 10, those are all operating systems for personal computers. Uh, even those that could be debatable as operating systems, like what was it? Windows Vista. That was a real popular one, wasn't it? Um, and uh, and then older operating systems like Windows 2000. I started out on DOS on PCs. So that's an operating system. And then, of course, then you had Windows 3.1, then Windows NT, Windows 2000, which was kind of the big revolution of the PC operating systems you see today, kind of evolved out of Windows 2000. But anyway, the purpose of an operating system is to basically um, allow software to be able to interface with hardware so that a mouse will do what it needs to do within a particular application. You get the monitor to display the way you want it to display, or if you have multiple monitors, that it'll allow you to mirror your monitors, or you can extend your monitors, that sort of thing. Also, you can often enter text commands in an operating system. The operating systems today, with the exception of Linux, are any are basically GUI operating systems. Uh, Linux is still command line, although it does have a shell that is a GUI shell that you can launch. So that's basically what an operating system is. In the world of Cisco, we refer to the operating system as iOS. And iOS, gosh, I don't even remember what it stands for. Um, but Cisco iOS is basically I think it's Internet Operating System. Um, is the operating system. It is a CLI, or a command line interface, which means it's not a GUI interface. Now, some Cisco devices have the ability to launch a GUI interface, but for most cases, um, Cisco Certified Network Associates, which is what this course is to prepare you for that certification. Uh, Most technicians use CLI, and it is the preferred method according to Cisco. Now, Cisco does have small business switches that don't have CLI. It's all GUI interface, but that's not within this course. This is strictly enterprise class equipment that requires CLI. But iOS is the operating system that's used on switches and routers and other Cisco networking devices such as ASAs, which is the Cisco firewall product line. iOSs have numbered versions for given Cisco networking devices, so the Cisco releases new versions of its operating systems on a fairly regular basis, at least annually, and then there's usually revisions to that. And then within an iOS version, there are feature sets that provide distinct packages and features of features and services. These are usually add-on features to the operating system to give it extra functionality, and they usually cost you money. Now, the Cisco iOS is contained on basically a chip within the device. It's called flash memory. The flash, which is non-volatile storage, and what non-volatile storage is it's storage that doesn't disappear when the device loses power. It's kind of like a hard drive in a computer. When a Cisco device boots up, it basically copies the operating system into RAM, and then it loads the config, and then off you go. You've got an actual functioning device. Now, the amount of flash and RAM that's required for a device depends on what version of the operating system you have and what feature sets that you have. So a particular switch or a router may have 64 meg of flash and 64 meg of RAM, and that'll probably work just fine for the base iOS. But if you have a special feature set of some type, for example, say a Cisco integrated service router may actually contain a phone system on it. Well, in that case, you may need a lot more RAM and a lot more flash and be able to hold that version of the iOS. So what the iOS does for the device is it does a lot of different things. It provides it has a security feature in it that makes the device secure, and also you can perform functions on it that will secure the data flow that goes through it. It does routing, which basically a Cisco device, if it's say a router, may have multiple interfaces, and so you can configure it to basically direct the traffic, based on its destination IP address. You can send it out a particular port. Quality of service, this comes into play, especially in voice, where you're giving voice packets or voice traffic priority over other traffic in the network so that you maintain a high quality of sound in your voice. Addressing, you can address the device so that each port on the device or each interface has an IP address. And you have interfaces on a Cisco device, which are basically the physical ports that you can hook into, and then managing all those resources. There's a little video here you can watch that talks about Cisco iOS and that sort of thing in terms of different versions, and getting yourself a CCO account on the Cisco website. I definitely recommend that you look at that. So let's talk about connecting to an actual device. There's several methods to do that. There's the console access method, and this is where you physically connect to the console port on the device. This is only possible when you're actually physically with the device, and that's when there's a console cable that you need to use for that allows you to connect to it, and it's usually either a USB on the other end or a serial cable that would plug into your notebook or your PC. that allows you to terminal into the device. And then more often than not, you can go in through the Ethernet port where you have the device connected to your network, and you can basically telnet to it. Telnet is a pretty standard terminal emulation protocol that you can install on any PC and be able to access the device that way. The weakness of Telnet is that all the traffic is clear text, so that any passwords you type in or anything like that, or and the traffic is essentially clear text. And if you had somebody sniffing the network, they could actually get that information. Secure Shell is the preferred way to access Cisco devices remotely through the network, and that's basically kind of an encrypted version of Telnet. The aux port, or the auxiliary port, is another method by which you can access, and the auxiliary port is basically where you could have dial-up modem access to the device, so that you could conceivably remotely access the console of the device, which sometimes you need to do if you need to do a factory reset, if you need to do a hard reset of the device because you lost a password, or that sort of thing, and other functions that would require you to be on the device. Switches don't have an auxiliary connection, but routers do. Now, accessing the device, whether it be through Telnet, Secure Shell, or even a console port, requires that you have some sort of a terminal emulation program. And there's a lot of different ones out there, and I think a lot of people use TinyTerm. It seems to be the one that most people use, but there are others that are out there. And in the packet tracers and labs, you get exposed to using some of that kind of stuff. So they just show you some pictures of different terminal emulation programs. And this little activity here kind of does a good job of telling you, the differences between different methods of accessing and what you can and can't do. I would know this pretty good. You're going to need to know that for a chapter exam. Then we get into actual navigating the iOS. So once you get in, there's a different modes, and you have a user exec mode, which as soon as you get into the router, it basically some very limited number of commands. And then you have the ability to move up to what is called privileged exec mode. And notice that in this case, this router called router just has that greater than sign there for the prompt, and that's how you know that you're in the user exec mode. When you go up in the privileged exec mode, the greater than sign turns to a pound sign. So you always know what mode you're in just by looking at that particular character after the device name. And then there's also global configuration commands, and those you always know you're in because it'll say config and then pound. And then within that, there's actually interface commands, routing engine commands, and line commands to configure different aspects of the device even further. So interface commands is when you're actually configuring specific ports on a Cisco device. Routing engine commands is, for example, on a router, is where you're configuring global settings for the router itself. And then line commands is when you're configuring virtual um, interfaces as opposed to physical interfaces up here. So real quickly, I'm going to get in a packet tracer here maybe, if I can find it. And what I've got here is I've got a 1941 router set up, and um, when you get into that, you'll see there's a CLI tab, and when you first bring up the device, it'll go through a boot up process, but eventually you're going to get to this point right here, and I'm just going to hit enter, and notice that by default there's no security on this device. I go right into user exec, and to get up into privilege exec command, I just simply type in enable, and to get into configuration mode, it's configuration terminal. Oop, I goofed. I'm rusty. Configure, not configuration. And that basically gets me into global configuration mode. It's really in the morning. It takes me a while to get my mind going. And then you can go into the various interface commands and that sort of thing. A couple other things I'll show you real quick, and I don't know how good this is going to come across on the screen with the resolution and all, but um, when you want to exit a particular mode and go back to the previous mode, you just type exit and it takes you back down. So you're actually bumping up and down within the different modes. If I do exit again, I'm off the device and I'm right back into user exec mode. So they talk about the different um, modes, and there's a real good video demonstration here. It's better than I even did, that tells you about the different modes here in 2136. And then we get into some basic commands like how to how you assign a host name to a switch or a router, and why do you want to do this? Switch is, as you can see, has multiple ports that your end devices plug into through your cabling system. Um, and in an organization, it's very likely that you're going to have multiple switches um, because you're going to have different cable closets and the like. Um, where host names come into play is this is where you can give logical names to the physical devices so that you can tell them apart. In this example, you've got 3 floors and a switch on each floor, and you've got a naming convention for each switch. I would recommend you have a naming convention that's somewhat descriptive as to where they're physically at. Drives me nuts when I go into an organization and I call one Alice and one Joseph and the other one Philip. I mean, it's like, what does that tell me? How am I supposed to find that physically if I got to go get to it? So I would recommend that you use names that are descriptive as to where they physically are located, if at all possible. The command to configure a device is real easy. You get onto the switch, you get into the global configuration mode, and you just type in host name and whatever you want to name it. And then when you do that, notice then the prompt changes from switch, which is the default, to SW-4-1, which is what I assigned the host name. That way, when you're logged on to a switch, you always know which switch you're on. Then we get into in the chapter about securing devices. You have the ability to secure the router itself so that as soon as you hit enter on the router, it's going to give you a password to get into user exec mode. Then when you type in the enable command to get into privilege exec mode, you can get yet another password that will allow you to get into privilege exec mode. You can kind of think of that as super user mode. And you can also have yet a separate password if you're telnetting or secure shelling into a device remotely. And then you also have the ability to encrypt all passwords. Unless you go out and you deliberately encrypt all passwords, if you print off a config, all the passwords are in there. And so whereas where you encrypt it, it actually encrypts them and they're not visible to anybody other than the person that has documented them someplace else. So they talk about that and the commands that are that are related to that. So you're going to want to go through that. The other thing that's often pretty used quite a bit is banner messages. Banners are basically what comes up on the system when you first access the router. This is where you can kind of put a disclaimer. This is a secure system authorized access only. You know, a lot of times for legal compliance you need to have that on there. So that's where you can do that. Now, Cisco has a configuration. This is where the user has defined exactly how you want that device to run. And there's a command here that's pretty handy. It's called show running config that basically displays the configuration so that you can look at it and see. And then you can, when you want to save your changes, because running config is basically what is in RAM. It's what is running right now as we speak. One of the neat things about iOS is that when you type in a command, it immediately, in most cases, affects the operation of the router or the switch. So that's something to think about. You know, when you get on a switch or a router and you start throwing commands in, you are affecting production. It's not like you're in a separate environment and for example, you know, if you're writing a program, if you've ever done any programming and you're banging in your code, and then you compile it, and then you got to move it into the production environment, and then until users load that particular program, they're not getting the change. Well, in a Cisco device, you put it in, it's live, it's hitting it right now. Now, like I said, since this running config is in RAM, if you if you lose power to the device, you lose all your changes. So it's very important that once you're comfortable that the commands you have put in are permanent, then you want to basically save that configuration by using this command, copy running config to startup config. So this is a little activity here that shows you the actual commands related to that. In 2-232, they talk to you about how you can capture your running config to a text file so that you can print it off, or if you need to see a hard copy view of it. And so in 2.2.3.3, there's a packet tracer on configuring initial switch settings. This is a good little exercise to get you comfortable with the whole process of doing basic configuration. 2.3 talks about address schemes. You've got physical ports, like I said, on a Cisco device, as well as on PCs, and you have NIC cards, etc. And one of the important aspects of configuring a network is your IP scheme, and that's the IP addresses, as you probably are aware of. So like on a PC, you got a couple different ways to get an IP address. You can manually configure, which is this example right here, or you can have it set up so that it automatically gets its IP address from a DHCP server, which is out of the box the way most PCs work. On Cisco devices, you've got interfaces and ports on your Cisco devices, and you also have the ability to address those ports as well in many cases. for example, on a switch, you can configure that switch to have its own IP address on your network. And this is referred to as configuring a switch virtual interface. And this is basically by getting in the global configuration mode into the interface mode, which is config-if. And so once you're in global configuration mode, you type in interface VLAN 1, which is the name that you're assigning to your default network on that switch, and you give it an IP address with a subnet mask. And then the no shutdown command basically then brings up that virtual interface on that switch. And this is what you have to do to be able to remotely access a switch through the network through TinyTerm or any other terminal emulation program. So again, with PCs, you can manually assign an IP address. You also have automatically obtaining an IP address. So that's again when you have a DHCP server. If you want to display what the IP configuration is on a PC that you actually are on, the ipconfig command is one that you really need to get familiar with. And what it does is it will show you the IP4 address, the subnet mask, the default gateway, which is where it goes when it needs to look for a destination computer that is not on your local network, or in this case the 10.82.240 network. If your destination IP isn't on that network, it automatically sends it out the default gateway, which is usually your firewall, or it's a router, or something like that. If you get this error, this means you definitely got something wrong on your network. It's mentioning the fact that you've got two devices on the same network with the same IP address. That's not good. So Packet Tracer 2325, implementing basic connectivity, nice little exercise that allows you to kind of get a couple computers talking to each other. Then they talk about loopback address and what a loopback address is, and that's basically the IP address that is itself on a computer, used for testing and the like. Talks about testing end-to-end connectivity. That's when you use the ping command, and you'll use the ping command a lot in labs where you will basically test that you can see another device on the network that has an IP address assigned. A ping command is basically saying, hey, are you there? And it'll reply, yes, I am, yes, I am, yes, I am, yes, I am, which is what these replies are here. 2334 lab, excellent lab, building a simple network. You're going to feel empowered after you get done with that one. And then configuring a switch management interface, which is basically a switch virtual interface, which is how you have to it's the thing you have to do first in order to be able to access the switch remotely. So that's kind of the chapter 2 stuff. So hope this helps kind of get you, in the frame of mind that you want to get in there and start doing some stuff as far as configuring things. I would encourage you that even with Packet Tracer, just practice a little bit and just, build yourself a little network. If you got a network at home, or you know somebody's company that you're familiar with, you can actually, with Packet Tracer, kind of build that network and see if you can figure out how to get it all working. Now, some of it might be a little advanced for you if you're not familiar with DHCP and the like. But, even doing manual configuration of the IP addresses, you should be able to get a switch and a router and working in a couple PCs and being able to ping between PCs, be able to ping your router or your etc. So I would encourage you to practice with that as you have time. So that is chapter 2. Hope you found it informative. And like I said, go through the chapter, the labs, do the packet tracers that you can do. Not all of them are assigned in the for a grade, but that doesn't mean that they're not great enrichment activities that'll just make you better prepared for the chapter exam and the hands-on final that we do at the end of the class. So you know, uh, anything you can find time to do, yeah, right. I would encourage you to do. So, all right. Well, that's all I got for now, and I'll be talking to you again real soon. Goodbye.